Action!
All right, lesson
Take that joke.
27, rational expressions, page number 125. Oh, that was my problem. I was trying to use this, I was trying to come up with a formula and all this stuff.
It's like,
How did the two y's add together minus 3?
Yeah.
so this one's +3. Then you get -3 then.
All right.
I know, I was
As far as rational expressions,
minus 10.
keep your finger there. Go back to lesson 11 for me, please. Which lesson 11 is back on page 62. On page 62, or 63, I gave you problems that look like this.
Hey.
Problems that look like that. And remember, without an equal sign, all you're doing is simplifying. You're trying to combine your terms. You're not trying to solve for anything. So that being the case, before you can combine terms of a fraction, what we did in this lesson is we had to find what? Common denominator. Yes. So in order to do that, what I said is find the smallest number that each of those denominators will go evenly into. So 2 and 3,
And 6.
2 doesn't go into 3 and 3 doesn't go into 2, so you have to find the common denominator, basically, the least common multiple, and Riley just said it's 6. So, how do I make this 2 a 6?
Times it by 3.
Times it by 3. Do the same up there. All right, how do I make this a 6? Same thing. And I make this a 6 by doing it times 2. Okay?
Write this down.
I don't care if you write it down or not. This is just kind of the intro for the next lesson.
Teacher, since
Okay.
assistant principal, since our principal's not
Focus here, please. All right, so we've got our 6. Now we have to look and see what else we're missing.
And
Here we have an A. What do we need?
A squared.
I need an A squared, so I'm missing an A.
Add an
And I'm missing
A. An A squared.
an A squared here. Cobran. And what am I missing here? Nothing. So I've got 3AK over 6A squared plus 3A squared P over 6A squared plus 6 over 6A squared equals 3AK plus 3A squared P plus 6 all over 6A squared. Okay, that was lesson 11.
Yeah.
The lesson that we're going into today is exactly the same, only different.
Exactly the same, only different.
Okay, exactly the same with a few little tweaks in there. The other day I told you when you have a plus sign between two numbers, it divides them into terms. So 3 plus A would be 2 terms. And when I said something about a plus and minus sign when you guys were talking about canceling. What did I say about the plus and minus sign?
Can't mess with those numbers.
You can't mess with the numbers on either side of the plus sign because that plus sign chains or locks the 2 digits together. If there's 2 plus signs, so there's 3 digits, you can't separate off any of those 3. Okay? You have to leave them alone. That rule will always be true. So when we get to this lesson, and I have 4 over x, and I have plus 6 over x plus a. Same rules take place, and we're going to add that rule that I had mentioned as far as plus and minus signs locking digits or terms together. Okay. Now, if you were to do this without knowing that rule, you would look at this and say, what am I missing here? I'm missing an A or a plus A. And what am I missing here? I'm missing the A. Okay? Doesn't happen. What this is an expression all of its own.
So you have like X.
So, if I ask you what I'm missing over here, you're missing x plus a. You're missing the entire thing because it can't be separated. What am I missing here?
An X.
I am missing an x. Even though I have one here, this is not an x. That's an x plus a. You can't look at them as separate. Now you combine them. 4 times x plus a plus 6x over x times x plus a. Can you do anything with that?
No. Yes.
You can distribute.
Okay, I heard distribute.
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 What did you say? I'm sorry. The X plus A. You can cancel them out.
Okay,
I lied. I'm sorry.
what am I going to do with that?
That's going to be your answer.
Riley's done.
You have to simplify the top, and you have to simplify the bottom.
I lied again. No, I'm kidding.
I want to be done.
Wait.
Okay, notice the bottom there, guys.
Oh, you don't.
You don't.
The only reason you would distribute it is if there's some possibility of you canceling or simplifying it even more. If I distributed that x, I'd get x squared plus xa. That's not helping me. So why do it? It doesn't make it simpler. You know, I really don't care, Elias, whether you do it or not. But usually when you've got a distribution like that and it's not going to cancel, you don't worry about it.
Put it over that.
All right, so let me give you one to try. Let's do x plus 2 over x plus 4 plus 6 plus 2 over x squared. All right, see what you come up with that. Okay, what are we going to multiply the numerator and denominator of this first term in order to have our common denominator? Erica?
X plus 4 times X squared.
Okay, we're going to do it by x squared. Is that what you said? Okay. Is there anything else?
No.
What is missing under the 6?
Oh,
Nothing. You know, you don't have to worry about that one. Okay.
Oh, that's squared.
Okay, what am I missing under the 6 that I have?
X squared times X plus 4.
X squared and x plus 4. And an x squared and an x plus 4. Okay, what am I missing under the 2 here?
X plus 5.
Just the x plus 4.
Yeah, that's all.
So you should have gotten x squared times x plus 2 plus 6x squared times x plus 4 plus 2 times x plus 4 all over x squared times x plus 4. Are we done at that point?
No.
Okay, why would you distribute? The top needs to be combined, simplified, if possible. Okay? One of the ways you can tell if it's even worth messing with is when we distribute, are we getting exponents that we're going to be able to combine? I mean, you should be able to just look at this and know we're going to get an x cubed here and an x cubed here, so that would be like, well, I can combine those then. In here we've got just an x here, so that's not going to combine. So not a lot's going to combine, but at least we know our distribution is going to do us some good. So x cubed plus 2x squared plus 6x cubed plus 24x squared plus 2x plus 8. All right. Is that going to help me at all?
No, you should add
It will help.
terms.
It will help me. So I'm going to add this and this. And let's see if I can. So what do I get then when I combine like terms?
So the next cube
Plus 24, X 26.
Okay, because I got these.
Oh.
Do I want to distribute?
Yeah.
But if I distribute this x squared times x, I'll get an x cubed, then I have an x cubed there.
There's the chain.
There's a chain. It ain't gonna matter. I can't cancel anyway. It'd be nice if it was multiplied, I could cancel. But since it's not, I can't cancel anything, so you might as well leave it
That is
alone.
gonna confuse me so much.
You could factor the x cubed out, but you don't know how to do that yet. Because when you factor out an x cubed from 8, it makes life a little bit difficult.
Mr. Leiter, we could have a party when we get halfway through the book.
Okay. All right, so
Wait, how are we gonna have
one
Jackson
more.
All
Day?
these different parties we planned.
Is that what you?
Can we like bring in the day forward or something?
x plus 2 over
Kangaroo parties. Oh.
Okay.
So fun.
So, any thoughts? Yesterday, I made a comment. Erica?
Are we supposed to make the first denominator into like the thing we did the other day?
Into the thing we did the other day. Factored into
Yeah.
two binomials. Okay, what was the F word that I used? That would get his attention.
foil.
Factor.
You're not foil.
Okay, remember I said before you do anything, you always try to factor first. So, and that's what Erica was suggesting. So we're going to leave our x plus 2 alone, and our minus 1 alone, and x plus 1. But her suggestion was to see if we can factor that into two binomials.
No.
So go ahead and try that and see what you get.
Right. Got it.
That should have helped a lot.
I
So,
forgot how to do. Oh.
what are my last terms?
Plus 1 plus 3 plus 2.
Okay. At this point, now I can start comparing. What am I missing in this first term here that I have over here?
And X.
An x. Okay, what am I missing here that I have over there?
X plus 3.
Okay, and that's it. So now I've got x times x plus 2 minus the quantity x plus 3 over x times x plus 1 times x plus 3.
Can you simplify the top?
All right, so we're going to try to see if there's anything we can make on the top that will help life be just easier. X squared plus 2x
Minus X.
minus x.
3.
What's that?
Minus 3.
Good. This is an important part here, to leave those parentheses on there, because if you don't, you're not going to distribute that negative sign on that positive 3 and make it negative. All right, over. Okay, am I done?
If you leave the one there.
No.
You gotta distribute it.
Then
What
you
do I
have
get?
X
Subtract the X.
squared plus X.
This is the one thing you do wrong.
Can I do anything there? I mean, if I distribute all three of those parts, I'm going to get an x cubed. If I just do two of them, I'm going to get an x squared. But what difference does it make? Because they're locked together with plus signs, so you can't cancel. So we're good at that point.
You
Pardon me?
factor the top.
Can you factor the top?
Doesn't really come out.
Yeah, give that one a shot. Two numbers multiplied together give you 3, added give you 1. Now, if it was a 2, you could use 3 and 1, because 3 minus 1 is 2, but you can't get a 1 back to 3 and 1, because those are the only ones. So, good thought. You always want to do that, especially when you have a trinomial up here like this. If it can factor to two binomials and they're multiplied, how's that going to help me?
Because you could cancel it.
Then
with
I can
bottom.
cancel because they're multiplication sign. There's nothing holding them together. Okay. Life good?
Yeah. Let's go to drawing.
All right, so that means we are done.